So here we go, Algebra. This is chapter 7.3, multiplying polynomials. Feel free to pause the video as we go along because I'm going to move sort of quick. So the first example is going to be the distributive property. What we're going to do is we're going to take the expression of this quantity and we're going to separate it, and we're going to multiply the first term with the second quantity, and then we're going to take the second term and multiply it with the same quantity once again. This is called the distributive. What we're doing is we're distributing these two terms to this quantity. So we have n times n, which is n squared, n times negative 4, negative 4n. Then we have 9 times n, which is positive 9n. And then we have 9 times negative 4, which is negative 36. We combine our like terms, and so we get n squared plus 5n minus 36. Okay, that's the distributive property. That's actually very similar to the last example I'm going to show you. We have two, by the way. Now here comes the table example. Actually, I don't know too many people who really use the table example too much, but it actually is a very great way to do this. So we have the quantity 3x plus 1 times the quantity x minus 4. What you do is, since this is a binomial, you'll make a square that goes 2 units wide. Since this is a binomial, you make it 2 units tall. If it was a trinomial times a binomial, you'd do a 3 by 2, okay? And you just put the products inside each cell, just like it was a multiplication table, which is why it's called a table. So 3x times x is 3x squared. And then 1 times x is just x. 3x times negative 4 is negative 12x. And then finally, 1 times negative 4 is negative 4. And then these two terms should be like terms, okay? And what we do is we combine, I'm sorry, I just realized I left the square off. And then what we do is we combine the like terms and we write everything in standard form. So negative 12x plus x is negative 11x. 3x squared is at the front because it has the greatest exponent. And then our negative 4 is our constant trailing up behind. All right, that's called the table method. I actually do really like it. I don't use it very often because it takes time to do, but I really do enjoy it. It's a great visual. All right, and probably the most popular method, which is called the FOIL method. FOIL, for those of you who don't know, stands for first, outer, inner, and last. And the truth is, you could do this in backwards order, LIOF, it wouldn't matter. But here we go. The first refers to multiplying the first terms. So it would be 4n times 2n, which will be 8n squared. That's first. Okay, your outer terms are the ones that are the most extreme in terms of distance. So this would be 4n times this 5 over here. So that would be 20n. Now pay attention to what I do with the next part. Now the inner terms are the two that are most inside. So that's negative 1 times 2n, okay? And that product is going to go underneath here, which is a negative 2n. And then finally, our last terms, the ones that are both at the end of the expressions. And that's negative 1 times 5, which is negative 5. And then what we do is we combine our like terms. 8n squared, positive 20n minus 20n is positive 18n, and then finally negative 5. Now I know I went through that quickly, which is why I told you to go ahead and feel free to pause the video when you wanted to.